Counting down, baby.
Example 3. Evaluating trig functions determined by a point not in Q1. Which quadrants are those?
All the others.
So 2, 3, or 4.
Yeah.
What does this change? That's what we want to look at. So I'm going to draw myself a picture. Look how straight my lines are.
Those are the straightest lines I've ever seen in my life.
Okay. -4, -6.
I feel like that's not quite perpendicular.
-4, -6 goes left 4 and down 6. So we're talking about an angle down here in quadrant.
Third quadrant.
Like this.
Third quadrant.
Yeah. So there's a point over here. This point -4, -6. And notice it's the same numbers, but now we've got some negatives going on. So we're basically looking at, all right, what does this change? Also, to draw this triangle.
Connect to the x-axis, baby.
Connect it to the x-axis. Never connect to the y-axis.
Never.
That's a terrible, terrible idea. Don't do it.
Yeah, yeah.
Go draw up or draw down.
That'd
That's
be like,
the only options.
If you connect to the y-axis, that's like something along the lines of Doctor Who not being able to solve a problem. He solves every problem.
Yeah, I don't understand what you're saying right now because he always solves the problem.
So you can't. I mean, that's how you have to. It has to be that way.
So theta is right here. It's this angle that is closest to the origin between the hypotenuse and the x-axis.
Between the what axis? I didn't hear you.
The x-axis and the hypotenuse.
Every time.
And then the -4 is our adjacent side. The -6 is our opposite side. Now, the angle we're actually talking about here is an angle that stretches all the way around. Okay? But what we're doing is we're using a reference angle.
Right.
And we're just looking at this specific triangle in this third quadrant. What happens is because we're including these negatives here, that takes care of the fact that we're actually talking about this angle that's bigger than whatever the angle in our triangle is.
Right.
So that's kind of a weird thing that it's like, oh, well, it's neat that works out that way.
Yeah, it works out perfect every time. So it's really important to make sure that all of your numbers are correct.
Yeah, make sure your negatives
with signage.
Are there. Yeah.
A hypotenuse on this.
Oh, so we did this one last time, and make sure if you're doing this that when you square you put in parentheses because otherwise
you're actually squaring the number -6, which means -6 times -6,
which is positive 36.
If you do -6 squared on your calculator, that will give you -36, and that's not going to happen. Remember, when you're working with hypotenuse, that has to always be a positive number, no matter what. It's a distance, it's a length. Like we have to have a positive hypotenuse.
Absolutely.
Every time.
It was 2 squared root of 13.
I believe it was, yes.
Okay, so our hypotenuse is 2 squared root of 13, and notice that. Or maybe you noticed. I don't know. Maybe you don't. I can't tell if you can read that anyway. 2 squared root of 13. That number will always be positive. Our hypotenuse will be.
I just said that.
Did you really?
You just agreed with me when I said that.
I knew that. I was totally listening.
Thanks.
Opposite over hypotenuse is -6 over 2 squared root of 13. Did you really just say that?
Yeah, we can play back later.
Okay, I'm sorry.
Might as well not even sit over here.
No, please. You're great. -3 over the square root of 13?
That's what I probably already said also.
No, I don't think you did. Now you're just being a big baby. Cosine
but it's the same
theta.
process. Opposite over hypotenuse, okay?
Yeah,
and in this case, that opposite side is -6. Sine, S-I-G-N, is super important here.
Right. The sign of the sine is sine of the sine.
That's going to be -2 over the square root of 13. Also negative because the S-I-G-N is negative.
Yes.
Yeah.
Tangent.
Opposite over adjacent. Now pay attention here because something wacky happens.
By wacky, do you mean the negatives cancel out and it's positive?
Yes, it's wow. If we go back to what we were just looking at a minute ago, the tangent is identical. Like if you pause your notes, rewind, and look at the tangent on the other problem, it's the exact same.
Or if you look above where you're writing at the previous example.
Yeah.
Either way.
Yeah, like if you look in your notes, those are going to be the same. And that's true. Like what we just wrote down for you that's a true thing.
Yeah. So secant of theta, no, that's not what I write next. I write cosecant. Sine and cosecant go together.
Yeah, sine and cosecant. You were one step ahead of the game.
Yeah. It was a close one. Cosecant theta. Flip this. Now when we flip, does that change the sign?
The sign has to stay there. It's still a negative. The only thing we do is look at the reciprocal.
Right. That's something that people tend to mess up on, is they think when you flip it, you change the sign,
No,
and
you don't. You don't change the sign. Just reciprocal only.
So
Same thing on the
negative
cosecant, or same thing on the secant.
Square root of 13 over 2.
Yes.
That's a 3 right there. That's
Yeah, it's a
hard
3
to tell.
and a 2.
And then
And
cotangent
then down here,
theta.
2/3.
2/3.
There you go.
Now, at some point, maybe we should talk about the quadrants. This, you know what I'm talking about? Like
Yeah, I know what you're
sine,
talking about.
cosine, and tangent.
Yeah, do you want to talk about that now or later? I mean, you're already drawing it, so let's
do it now.
just do it.
Okay, so what happens is sine, cosine, and tangent, which I'll represent with S, C, and T, all three of those are positive in the first quadrant.
Right.
Okay, if you have an angle in the first quadrant,
Everything's positive.
everything's positive. Here in the second quadrant, well, if we look at, if we think about what's going on here with a triangle, okay, we have a negative for our x and a positive for our y. Okay, for a point that's over here. So sine, which is y over our hypotenuse, so positive.
positive.
That sine will be positive. But cosine won't be positive because it's adjacent over hypotenuse.
And the adjacent this time is negative x.
Right,
So a negative divided by a positive has to be negative.
Right, and then our tangent would be negative because it's y over negative x, so that's a negative number.
Right.
Okay, so sine is the only trig function of the original 3 that is negative in the second quadrant. So,
That is positive in the second
yeah,
quadrant.
that's what I meant. That's positive in the second quadrant, and so is cosecant since they're reciprocals of each other.
Right, but all the others have a big old negative SIGN on
Yes, on quadrant 3, we did this problem right here. On quadrant 3, tangent was the only one that ended up being positive.
them. Right, and we just saw that one, so
Yeah. So in quadrant 4, what's going to happen is our x is positive, but our y is negative, and that means that
all the cosine stuff is going to be positive.
exactly. And there's a way to remember this because we have all in the first quadrant, we have sine in the second, tangent, and then cosine. Do you know this?
All students take calculus. That's how I remember it. How do you remember it? Do you have a different one?
Mine was all smarties take calculus, but I mean, they can just be students if you want them to be. Okay, either way, if you remember that, you have A, S, T, C goes around in the quadrants. Those are the trig functions that'll be positive in that particular quadrant.
Yeah, there you go.
So if we were like, hey, what trig functions are positive between 90 degrees and 180 degrees?
You should be able to tell us.
Exactly.
Yes.
I think we're done here.
Okay, good talk.
Okay.